Okay, Assalamualaikum and a very good day everyone. In this video, we're going to look at the third part of chapter 5, which is virtual memory concept. So, but before we go to the concept of virtual memory, let's take a look at slide number 16 in our notes. So if we refer to slide number 16 in our lecture notes, so you can see we have this figure over here, isn't it? So in this figure, we have what we call as MMU over here, which stands for Memory Management Unit. So what is actually Memory Management Unit? So Memory Management Unit is actually a mechanism. It's a mechanism. Okay, so what mechanism is that? All right. In general, for a computer-based system, so when we open our program, so we can see that if let's say we have many active programs at one time, isn't it? So we can see that as if the program runs at the same time because of the speed of the computer that it provides us, right? Okay, so if let's say we have many programs open at the same time, it looks as if all these programs are running at the same time. But actually, all these programs are running accordingly, consequently, one by one. Okay, so who actually organize the program's execution such that it appears as if it is running at the same time at any instant? So this is what memory management unit do. So it's a mechanism that provides a rapid switching between this program so that it appears as if all programs are running concurrently to us as human. Okay, but by right, the machine are actually running the program one by one. Okay, so this is what we call as a memory management unit function. Okay, can you see that? So that is the function of memory management unit. So another thing in this figure that we have, the term here is virtual memory. So what is actually virtual memory? So virtual memory is in general, this is a concept, all right, in a computer-based system. So we have what we call as physical memory and virtual memory. So virtual memory is actually a memory that exists in the backup space usually in a hard disk, okay, that supports the system whenever the physical memory is full. Okay, so physical memory ni apa pula? Okay, physical memory itu is the memory that is already in the computer system which has its own address available to it. Okay, in the whole memory of the computer system. Okay, for example, if let's say in a system, it states that it consists of 4 kilobytes memory, for example. So 4 kilobytes memory usually is available on the memory chip itself. Okay, the one that we usually draw in the box of space with address, kan? So that one we call as the physical memory. Okay, something like this. Okay, so we usually draw the space like this, which with its own address over here, isn't it? So this is what we call as a main memory. Okay, usually it is the physical memory available on the board itself, or on the system itself. Okay, or board on the system itself. Alright, so this is what we call as physical memory. But in some cases, where the computer system supports virtual memory, so if the space in the main memory or in the physical memory is already full, okay, the space is already full. So if it supports virtual memory, so the data will be written to the virtual memory, which is usually located in the hard disk of the system in a backup space. Alright, so this is what we call as virtual memory. So for this kind of system that supports virtual memory, okay, so the cache can be located either in between the processor and the main memory unit, or in between the main memory, the physical memory, and the main memory unit. So you can either, the cache memory can be located here or somewhere here. Okay, so how can we determine which which is the placement of the cache memory in a system. Okay, so this one will be depending on the cache itself. Either the cache core supports a virtual memory or not. So if the cache core supports virtual memory, so it can be placed in between the processor and the memory management unit as indicated in the upper figure over here. So for this kind of placement, so we call this cache as logical cache or virtual cache. Okay, so virtual cache, so we call this as virtual cache, okay, because it supports the virtual memory addressing. So it doesn't need the memory management unit to translate the address for it, okay, because this cache can support virtual memory address. But if let's say the cache core doesn't support the virtual memory address, so it needs to be placed in between the memory management unit and the main memory in the system. So why is that? Because the cache needs this memory management unit to translate the virtual address given by the processor, okay, before it can find the data or before it knows which data that needs to be accessed by the processor. Okay, so this kind of cache, we call it as physical cache. Okay, another thing to note is that we have this, recall that we have two architectures in a computer system, isn't it? Okay, so we have two architectures in a computer system in which we have either the Harvard architecture versus a von Neumann architecture. Okay, so recall that von Neumann architecture has the same or a single memory space that can store both program and data, isn't it? Okay, so for this kind of architecture, it only use a single cache to support the memory system, in which we call this as a unified cache. But for the Harvard architecture, okay, Harvard architecture, so as you can recall, it has different space that or different memory space to store the instructions or program and also to store the data memory. So in this kind of architecture, it needs to have two cache, okay, to support each of these memory access in the system. Alright, so this one we call it as what we call this one as iCache and Dcache. Okay, so iCache stands for instruction cache, which is in between the instruction memory and the processor, while Dcache is a data cache, which is located in between the processor and the data space or data memory. Alright, so just now one cache we call it as unified cache, and this kind of cache is known as split cache. So this is the different cache type depending on the architecture of a computer system.